There are different things you can do. So you can create a call library from scratch. You can build onto a call library. So a lot of what we did, we added call types to an already existing call library so that we really expanded what we were looking at, but didn't lose all the stuff from before. And you have our call library. So if you're doing stuff in the Northeast with the Bailey and Wells species call types we're using, please feel free to use that, build onto it.
There's call libraries from Western Chile, call libraries for US West Coast. So,
Yes, if you didn't hear that, Mark was saying there's call libraries that have been built for Chile, Eastern Chile? Well,
Chile.
Western, sorry,
Yeah.
Chile.
Chile.
And
West Coast.
West Coast.
US West Coast, SoCal, Southern California.
Yeah, so within the LFDCS family or user group, there are other call libraries available, so it's always good to just check in before doing anything to see if we can save some work and share. One thing, if you are ever going to build on a call library that's existing, I suggest just making a copy and have one that's your working. Kind of anything with LFDCS, you always want to back it up. I mean, anything anyway, but backing up is always good because there will be overridden things. So the reference guide shows you kind of how to create one and add exemplars. I'll just show you first we'll open it up and examine the call library, and then we can look at how you might add an exemplar briefly. So don't think this is where we're gonna be live and do this together. So the Manage Call Library program is, this is the one where you go to evaluate and look at all the different pitch tracks or the exemplars that you put into it that make up each call type. And so it's just, you would start the same way you would for the other programs. You go into your process directory, you open IDL there, and then you do Manage Call Library and you specify the call library file. And so, which I didn't mention earlier in the reference guide, we show kind of the general code and sometimes what is supposed to go in there. And then below, we'll show an example of what that actually looks like for an existing file, just to give you what it should be and then what an example of it looks like. So we can just even copy this line of code and we'll look at the GOM9 call library. So when you come to your terminal, and anytime anything is done or you've run something and you've exited appropriately, there's the IDL caret, and so that means it's ready for your next program command. Okay, so when you call the Manage the Call Library program, it lists all of the call types in your call library. So that's your first column. The second column is the number of exemplars that make up that call type. And then the rest is the metadata that you've described as you create those call types. So what species does that call type belong to, the name you've given it for that call type, and the description of that call type. So in the case of LFDCS and how it works, we've created five different call types, 5 through 9, and we've specified just how they're different. And that increased the probability that we would catch all the variability in right well up calls, because they aren't, the same exact call every time. Having these 3 to 5 different call types helped us to make sure we were capturing the different variable up calls that happen. And just to show what they kind of look like, we have like the up call that's 100 to 200 hertz, the check up sweep, which Mark eloquently describes as the attack with slight down sweep and then rapid up sweep. But you all know the check up call, that typical beautiful check up sweep. The rapid up sweep ending around 200 hertz, a short duration up sweep, and a 90 to 250 hertz long up sweep. So again, kind of capturing different ranges. And these were developed as you're adding exemplars. So we call them exemplars, being an example that was added to the call type. So as you develop this and look, you'll see how they form, and in that cloud that Mark showed earlier, you see where they fall, and that helps you understand whether you should split a call type into multiple or whether it seems like it's a good fit for that. So this is for the GOM9 call library. So then you can start exploring each call type if you want. So what you do is enter the call type you're interested in. So let's just stick with right whales and we'll go to 5, hit enter, and a bunch of windows pop up. So the 3 windows that pop up that you're looking at, this IDL3 are showing you all of the pitch tracks of the exemplars that were added to make up that call type. So when you're thinking of what it would pick up, a call type that, or a detection that would fall into call type 5 is going to look something like this upsweep. It also has the number, that exemplar number down below, so you can't read it great, but we'll go through showing you how you can cycle through them. There's then, this is kind of that two-dimensional cloud, showing you how close the parameter, all the exemplar values of that parameter kind of fit with one another.
For each attribute.
For each
Yeah.
attribute, yes,
Yeah.
sorry. So those 7 attributes Mark had explained earlier.
There's 8. The last one
8.
is the Mahalanovas distance.
The Mahalanovas distance is this one. And then in this window, the IDL 0, that's showing you the distribution of each of the attributes for all of the exemplars. And so typically a good call type, we would say, has a normal distribution. So these kind of single humps. If you're building a new call type or you start adding exemplars to one and you start to notice that you're getting a non-normal or bimodal or something where you might have 2 humps, that's a really good indication that that call type should be split into 2. So this is the general overview of what you get when you want to start looking at things. Then if we go back to our terminal window, there's a bunch of commands you can then do. So again, the letter in the bracket is showing you the letter to type for that command for what you want to do. You can first, we'll do case or next case. So if you type N, it will select the first exemplar. And so you might not be able to see it, but it is highlighted in yellow. And we'll just go a little forward. If you keep hitting N, it's going forward and selecting through. And so right now, this one's highlighted and this one is selected. And the dot is also highlighted in yellow. And it also shows you where it falls then here on the graphs. So that exemplar that's selected, it'll show you where it falls on all of these. So you can go forward a case, back a case with the B, cycle backwards through this list. You can delete an exemplar. So as you're building, you might have added one by mistake. You can, when it's selected, hit delete. You can delete an entire call type. You can change the max min. I don't know what that does actually. We'll find that answer later. You can modify the call type information. So that's where the descriptions. Oh, good, great. I'm glad you do. I don't know where. I think it went through and added a bunch. Anyway, information, modifying the call type information. That's that, right whale, check up sweep. With those nice words of describing it, you can change that. Change call type. So if you have an exemplar that you have highlighted that you would suit better in a new call type you've created, you can move it here. You can add a call type. So you've looked at this distribution and suddenly you think you need to have 2. You can add a new call type here and then start moving those cases over or those exemplars into it. You can actually pull up the spectrogram view of the case if you want. So we can just see what that looks like there. So that's showing you that exemplar that was taken from data. That's one of the up calls in there. You can, let's see, move the case
Change
to a
call.
different, so I messed
Change
up.
call types just to view another call type.
Oh, okay, so
T.
change type. change call type T is to view a different call type. So we could, if we wanted to change,
I'm gonna want the Q together on
oh
this.
goodness, this is good, I'm learning. Okay,
Now T.
so T.
Other.
So now we can switch, let's say now we want to look at 6. You can sort of see the checks in there. Sorry, so then O was to move that case to a different call type. So if you were splitting or creating new ones and you had a bunch of call types in one call type, this one is what you would use to move it to a different one. Speed and volume, you can listen to the spectrograms. So you can hit P and it'll play that exemplar. You can then use your speed and volume to adjust accordingly. And then you can loop through calls to compare. So that's kind of how to navigate through. The other thing that's listed here, when you click on a call type, is it then lists all of the exemplars that were added, and it gives you the different information about them. So I believe this is the date from the data that you've taken. One thing to be aware of is it doesn't tell you what data set it's from. So if you are building a call type, it's really helpful to keep a log and make a note of, exemplars, blah, 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 through blah, blah, blah are from this data set and this recorder. It's helpful if you ever need to go back and reevaluate, that's good to know. And then it does tell you what each of the columns are for. So it tells you the values of all of the different attributes for that exemplar, the exact values as you cycle through.
Want to know what the min-max is?
Yes.
So the min-max is one of the things that show the plot. So this is a very well-formed call type. As Jen said, that distribution is pretty multivariate normal, although you could make an argument for the AWS one. Anyway, there really aren't any outliers here. There aren't very many. So there are some tools to identify outliers and kind of view them a little better. The trouble with outliers is that they can screw up the multivariate statistics, which will in turn affect your discriminant function analysis. So you want to be really careful about outliers. So that min-max will set a minimum maximum for a certain attribute, and it will display in red all the cases that are outside of that min-max for that attribute. And it'll display them on all of these plots. So you can, if you've got a bunch of calls that are a little longer in duration than the other ones, and you want to take a look at them specifically, you can set the max duration time for whatever and see all the ones that are longer than that call. So it's just a way to try to figure out if an exemplar really belongs in its call type.
Oh, I didn't know that. The other thing is, as you're building without the min-max too, if there is a call type, if there is one exemplar that is really an outlier, it will highlight in red as you're going. You want to be careful if you're just starting to develop a call type, because if you don't have enough exemplars, there's a lot that's going to be red, and then as you delete one, new one will become red. So it's a kind of a game of creating as much as you think might fit, and then playing from there and kind of adjusting as needed. Typically, we say, you want to get a very wide variety for a call type. So you want different individuals, you want different times, different places. So if you have a really good period of calling, you really only need a couple calls from that calling bout. Otherwise, you're really kind of building a call type based on an individual, and then it's not going to work as well in other variations. It's also good to have different amplitudes of that call, different qualities. You don't want the best quality of that call every time, because then if you have poor ones, it might not get picked up as well down the road. I think we've typically said like 50 to 200 call examples per call type seems to be a good number. Once you get kind of past that, it doesn't actually improve the call library very much. So if you get a good solid variable all-encompassing call type, it should suffice. And that's where you can then play with trying to see if different call types help or not. I do find, we have a humpback whale upsweep call type. that sometimes works well to separate between upcalls and not, but it's tough. I think it's, you know, as we know, this year's humpback song looks identical to a lot of upcalls, so it's not going to be perfect. And I would caution including those call types from this year's song as a humpback classifier, because you'll probably then get a lot of upcalls put into that category. I know some groups actually use the humpback whale upcall call type in looking for right whales too, to make sure they're not excluding right whale calls. So it's kind of a, just because we labeled it one thing doesn't mean that is, you know, how you have to use it. It's kind of what the goals of your analysis are and what it's going to pick up. Just things to keep in mind. The one thing I don't think I showed with the other browsing either is with this, you want to quit out of any program. So Q will get you out of the windows will remain, but it will exit in the computer. Otherwise, if you only X out the windows, it doesn't actually quit the program and it gets kind of locked up and the windows get all wonky. So you just want to make sure you hit Q here, and in the browsing window, there's a quit button on the bottom that you hit. And we'll do that if we're going to build just an exemplar here just to see what that looks like. So let's say we want to add some exemplars to the call library. I'm going to do it this way, where I'm going to take our pre-existing call library and make a copy. And we'll call this GOM9 test for addition. So we'll just see what it would look like if you wanted to add an exemplar to a call type. Again, you can add a call type yourself, and then, well, we could do that here. So we'll get out of these windows. And this is where I'm going to go back to my trusty reference guide. And I believe building a call library is up here. Yes. So for this program, it's find exemplars. And if you were building a new call library, I believe it's the program above, and it's create call library. So here we're going to add on to what we've already established. And it's find exemplars, and you go to the LFDCS index file and then the call library file. So this LFDCS index file is the file that's from the processed data. So if you are going to build to your call library and add exemplars, it has to be from data you've run through LFDCS. It's fine to have run it through with a different call library. It doesn't matter what call library you've run it through. You can reclassify anything. It's just, that's what gives you the pitch tracks too. If you do run it on a completely different call library that you're building, it will give you suggestions of what it thinks that pitch track will most likely fall under. So you can ignore it, but just know that you're going to get that information. So as an example, I'm just going to copy this and then we'll readjust. Oops. So, oh, there's more. Okay, so with all programs, there's commands, and so we'll want to specify things. So I'm going to open up my code file so we can stumble through this together. Okay. Oh my gosh. I don't know. Okay. And I didn't copy everything. This is so fun doing it live, everybody. I'm glad you're all with me throughout this. Oh boy. Okay. So first thing is find exemplars. We then want to direct it to the file index. And so what we can do is we go to our test data set on the process. And if you click on the, well, actually, fun trick, you could drag it right to where you want. No. I lied. It used to work, but not right now. Command I is the shortcut for info, and you can then copy the path there, dump it there. And then we want to have the LFDCS index file. Oh, we have a typo in the file. It's not plural. Okay, so then you want to direct it to the call library index file. So for us, we're doing GOM9. And this will be
Underscore test. The directory is gone. CLND
Did I mess up?
test, isn't it?
processed test
No, that's
underscore
fine.
data set.
That's fine.
Yes.
Call library.
Call
Remember
library.
you duplicated?
Oh, I duplicated it. Yes, thank you. So this is why it's always good to then go in, because you'll get an error and be like, what did I do wrong? I'm gonna copy this and oh okay, I think that's fine. Yes, thank you. Okay. Okay. So there are other things to add. So it's going to bring up a screen like we looked previously with the browse auto detections, but the buttons this time will be the call types you want. And so there's only so much space for the call types, so you want to specify numbers. And so we can just take what we put here for now as an example. But you would want to do, if you have call types in mind that you're going to add, you'll specify which ones to add here. There's a lot more things you can do. You can specify if you have a new data set you ran and you want to browse through pitch tracks and you know the frequency range that the call is going to be in, you can specify the min and max frequency. So there's all the commands here that you can do to specify so that you're not going through every pitch track in that data set, but the ones that are most likely going to fall into that call type or call types that you're interested in building. So they're all listed here with the description of what that command, additional command can be, and then an example of how you would add it into that code line so that it should work. So for now, we'll just do this. Okay, so you'll notice it looks very similar to the browse auto detection window. I did not specify pitch tracks in a certain frequency range or duration, so we're seeing pretty much everything here. Well, my axes are a little off, but bear with me. Okay. So same as before, your highlighted pitch track is the selected one. If there's multiple pitch tracks, you'll see they just are white. And again, the color is based on the amplitude of the call or sound. You can page forward to go forward ahead of all of these pitch tracks on the page to bring you to the next centralized one. Same with page back. You can also do the same of clicking on either side. So same exact functionality, very similar in terms of navigating through the pitch tracks. Zoom in, zoom out. You can jump to a date if you know where you have calls that you want to add. Just jump to them. You can change the playback volume and speed. There's an audio filter on and off. You can play the range, the frequency range, hide the pitch tracks, compare audio. The additional button here is add a call type. So as you're going, you can also add a call type here, just like you would if you were in the manage call library button, manage call library program as well. So then once you are on a highlighted pitch track that you want to add to your call library, you can click on the button you want to add it to. So thankfully we added Pinwheel Pulse here. I'm just going to click on it. And that exemplar was added. Oh, there's information we're missing.
Yeah.
Did I mess up?
Yeah, well, it's when you resize the window. It's not very
Okay.
clever about
All right, we'll have it small. Another handy tip is if you do the up arrow in your command line, it'll bring you back the last thing you just did. Okay. So we're gonna look at the small window for now, because what it does is as you are on each pitch track, there's information below that comes up. So it'll give you the date and time, the amplitude of that sound that's pitch tracked, the frequency range, so the min and max of that pitch track, the duration of the pitch track, and then it'll show you the top 3 call types that that pitch track would be classified as, or where it's closest to, and with the probability and Mahalanobis distance, as Mark was explaining earlier in the tutorial. So this can be misleading if you're creating a new call type, but it's there if you already have ones that are pretty established and you might want to add to them. Or if you have like 3 upcall call types and you want to know which one it fits best in with. But I think we've always talked about it's best to kind of ignore that, because if you're building a call library, you don't want to look at the pre-existing ones in general, but it depends on what you're doing. Okay, so let's just hit pinwheel again. That's more like it. Once you find a pitch track you want to add as an exemplar, you click the button and it boxes the pitch track in that color. And so since this is a test, we can just show as an example, say I wanted to make that an up call, it'll box it in that color. So you can see as you go through the colors, like if you went forward and then came back, it's there.
I don't know if you noticed, but the statistics changed when Jen added that to the up calls. The probabilities in MDIS changed because you just added the call to the call library. It reclassified that according to the new call library and gave you the new classification. Of course, she just added a total outlier to the up call.
I messed it up.
No, that's fine. That's instructive because the numbers changed significantly. And now it's was it call time 18? Call time 18 before?
I don't know if that was the first one.
Yeah.
But so then this will lead us to another thing you can add in the export sheet is you can list for each exemplar the top 3 call types, probabilities, and Mahalanobis distances for that pitch track. So if you are doing something and you want to evaluate them, or you want to see, okay, so if I selected call type 5 through 9 for right whales, but what if I left out 18 or so? It's a good, you can have that information available. Yes.
You want to do something fun?
I do.
Quit out of this and go to manage call library for that call library.
Oh, that's
Call
good.
9 test.
Yes.
And let's look at call type 6.
Yes. Okay. So I hit quit just to verify again. Quit on the program so you can close the window correctly. I'm gonna go up to, and we're gonna go to manage the test call library where we just added a new exemplar. And then we're gonna go to call type 6. And look at that beautiful outlier that I just created.
It's colored red.
It says wrong.
You can see its pitch track. You can see it in the Mahalanobis distance if you can put the cursor. Where is it? Right there.
Yep.
Yeah. You can see it sticking out, and you can see it in this here. You can see it sticking out too.
Oh,
that's
way
it.
out here.
Yep.
So if we select it, and I think I can go back.
So, okay, so you see this, why don't you enlarge that so we can see
Which one? This one?
this one, yeah, I don't know if we can see it. Reduce the size of the print.
Yeah.
Yeah.
Oh, yeah.
Okay, see that asterisk there?
This line?
Yep, see the asterisk by 8.41? Ignore the asterisk by the time. But this asterisk says that this is an outlier. And this is where that min-max thing comes in. You can identify other outliers by setting this min-max, but it's automatically looking for I don't know, a Mahalanobis distance of 5 or more or something. and it's automatically identifying that as an outlier. And so this table can be useful for identifying exemplars that maybe shouldn't be in this call type.
And so say you did that, oops, and we want to delete it. So we actually can see here, so this is exemplar number 3800. We can select that case, select case, so C, and then you can say the index, so 3800, and then it'll select it, and from there we can delete it. E. No, D. Don't do E, or you might cry. This is why we have a backup anytime you're going to do something, because it's very likely. But it does ask you, are you sure you want to delete index number 3800? Why, yes, we do. Hit enter, and then it's gone, and your call type is back to beautiful. Yeah, so that was fun. That was a quick intro to that. It's again, it's it's a lot of playing, I think, but important if you are going to add stuff to have varying data. So if you know you're going to have noisy data sets, make sure you add exemplars from noisy data sets and maybe some quiet ones, and a good spread is the most important thing. I think that's the only other thing I was just going to briefly describe was how we do daily presence protocols, just to show how we do it. So
Sorry, Jen, can I just
There are
ask
some
a question?
diagnostics for call libraries. We won't go through them today, but they're in the manual. Things to check to see if your distributions are multivariate normal, scatter plots to help you assess outliers, or as Jen was saying, whether you want to split a call type up into two call types. So there's some things to try to help you get a handle on this 7-dimensional cloud that you're trying to manage.
I'm just going to scroll us to
A question before we move on from the call
contents. And so just to show you, so we have all of the different programs. There is a manual review data set if you, manual review program that's in here if you do want to go through and just box calls and have a log of calls without classifications. So that's in here and explain if you want to play with that. Then the data export we went over to show those. The exporting metadata is actually another helpful thing. So if you want to go back and see what you ran, what you put in your parameter file, you can use this program. So it walks you through it, and it just explains how you have to open your directory to a folder in the spec audio or the LFDCS file, depending on what metadata you want to pull out. But if you open IDL in that directory and then do ncdf info and direct it to just one of the .nc files, you'll get a bunch of metadata out. And so that's one way we've used when running through a lot of recorders and multi-channel data. Sometimes the wrong recorder was run, and this is a good way to be able to tell what the raw audio was run on, and other information that you put into parameter file. So this can be really useful. It can give you the call library that was run if you didn't have a specific name under there. So that's helpful. Yeah, and so this just shows you the terminal output of what you'll get. And so it just lists all the different information of things in the parameter file and other things you may or may not need to know. It's all there. So in the guide, the appendices we have, there's an example of a parameter file. Again, you have them in your distribution with examples that you can just make duplicates of and adjust to what you need. But it lists everything here, and then all of the parameters that you can adjust are listed with an explanation of what they are and what to enter. So if you have any questions, hopefully this is answers them. So the other thing we added here was just to give an idea of how we do daily presence. So this is how we run through all of our data sets and score using LFDCS output. to determine whether or not that species is present for that day. And we have, what we do is we use that export summary auto detections program where we get, for all species except fin whales, we export daily summaries, so over 24 hours. And then we build off of those sheets with different columns for our analyses. And so the first part here, the first part just says what we use to mark as present, possibly detected or not detected for each species. And I'll go through them briefly. But then the other part potentially might be at the end, shows what the files look like, which well, let's see. Oh, it's under export summary sheets. So we put it under the program and just showed you what we do for each species. We have slightly different columns that we attach for each species just to help us understand different things. Again, whatever you need to know is helpful. So for right whales, our criteria for right whale daily presence, where we say they were detected, we give it a value of 1 for that day. And that's if we find 3 or more true detections. Once we get to 3 true right whale upcalls, we'll jump to the next day and look for those there. Right whales, we've been very conservative for because we don't want to say they're there when they're not, and because humpbacks can be very confusing. So we use that 3 as a really conservative way to determine if they're present. We do have a column we call the true tally column, where we mark if we find only 1 or 2 upcalls. That day gets marked as possibly detected, but then we keep that information there that, well, we did actually find 1 or 2 true detections. And depending on your analysis goals, you could then always go back and take that in. We also keep the timestamps. You don't have to do this much because you could technically export your auto detections and get the timestamps and get the markings. We just found this to be, for someone, if someone wasn't intricately in LFDCS doing things, this was a second backup as well to not lose any information. We also keep track of unknown timestamps in case you're going through and you're finding call that might be a right whale, might be a humpback, it might, who knows, but you can keep track of unknown times in there too. We also, because we were doing a conservative 3 calls a day to be detected for right whales, had a suggested daily presence column where, say that 1 or 2 upcalls you found were beautiful, I don't want to lose that day, so we would say yes here just to really not forget it in case we ever changed our protocols as well, and a notes column for all the species. So just quickly through the other species, for sei whales, we use a doublet or triplet occurrence as presence. So if 1 detection is within a doublet or triplet, that was a day marked as present for sei whales. Single sei whale downsweeps, because blue whales can make identical ones. We've got so many downsweeping animals around. We really wanted to be confident when we had them, so we did the doublet or triplet. And we should know a lot of our missed detection results were also based on our criteria for daily presence. So there could be single sei whale downsweeps that caused that missed detection rate to go higher because we didn't accept them. Fin whales are the one species that are different. So because we narrowed down the output we look at, again, using at the number we found for 29 or more detections per hour, we actually export fin whale sheets in hourly presence. We're showing the daily here is the summary. Actually, that's the wrong daily presence sheet for fin whales, so we'll ignore it. But what we do is we do the hourly and we'll filter in for the hours that have 29 or more detections and then look for that. And if the first hour has fin whales, great, we go to the next date with 29 or more detections, so skipping as many hours as needed. Blue whales were the one species we do Mahalonovus distance of 5, maximum Mahalonovus distance. They really didn't have a whole lot of false detections in there. They're pretty good for the detector. It works really well. And for them, we determined presence if we had 1 true detection within a 4 calling period. So if there are 4 calls in a period with at least 1 detection, we said that was a blue whale present day. And then humpbacks, they produce the most detections. Just as a caveat, there's a lot of detections to go through. We said humpbacks are present if you get 1 true detection within 3 calls within like a time window. And a time window where you can see enough is about 10 minutes. Sometimes that's too far back too. So whatever you can see and able to determine what's present and get a good picture works. So that's just an example of how we do it using a detector output. And yeah, I think that's all I have for the end of our LFDCS tutorial operational program. Before we jump to real time. Does anyone have any questions?
I'm answering some questions from
Oh,
Anita.
great.
Why don't we, actually, why don't we do this exercise for Anita?
Okay.
So Anita's asking, how do you add a call type? Let's
Oh,
do
yeah,
it
we can
from
do that.
find exemplars, because I think that's what Anita's looking for.
Okay.
So make sure I've got this right, Anita. You're in find exemplars and you decide, oh, I got to make another call type, and you can do it right within find exemplars. Go ahead.
Yeah, okay. So, and you'll notice we opened it and it shows exemplars you previously boxed. So if you're coming back to it, it'll show you what you've already added. Okay, so let's say we want to add that squiggly as a new call type. Looks cool. Say add call type. It asks you, so then again, anytime you add something where you need to fill in, remember you have to come to the terminal. So it says, are you sure you want to add a new call type? Yes, I do. And then we'll give it a number. And so just to see an empty number, actually, what happens if we give it a, should I try?
No. Let's
No.
not do that.
All right, so we're gonna go to call type 30 as our first new number that's available. And this is where you then add the metadata. That's what you see when you call up manage call type. So the first thing is the species column, then you give the call type a name and then a description. So we'll call this unknown for now. I'm gonna call it squiggly. Small, short, tonal, warble. Contributor of call.
Anita.
Oh, or you can put whoever's doing the analysis. Okay, add a new call type with this information you just entered. Yes, so it asks you again in case you're like, well, that was stupid. And
Now it might have added,
oh, but we had too many.
I don't know if it's, yeah, it might have added a button and there's too many on there. So you might just quit out and
Yeah. Add call
replace
type
10
30.
with 30.
Yeah, I think in general, what do we say? Like 8 is the maximum. 3, 4, 5, 6, 7, 8. So if you had like 4 or 5, it should automatically add that button there. Just the window only does. Yeah, I'm pretty sure. I think
If
I remember
not,
that happening.
Go out.
Yeah. But then here, the unknown squiggly.
And then you can go
Populated.
add that.
Oh, yeah.
exemplar.
Where was it? Oh
That
no.
was right. That was right after the hard drive.
2. Yeah, I think
There
there,
it is.
squiggly.
Squiggly.
So then we would go squiggly. Yeah, so it would automatically populate if you didn't have 8 buttons already there, and then you wouldn't have to go back and find that.
And you notice it would have reclassified all the calls. You notice it didn't put this call into call type 30. It still has call type 17 as the most probable call type. You need at least 7 exemplars in the call type in order for it to be a legit call type. And so it's not even bothering including call type 30 in the discriminant function analysis at this point. So you have to build up a bunch before.
And that reminds me, if you add in a new call type, you have a new call library, you have data you already processed and you want to rerun it, you can reclassify that data and it will reclassify it with your new or additional call library. Again, back up your old LFDCS folder because it will overwrite it. And then the only other thing with that to keep in mind is if you've already marked up calls as correct, incorrect, or whatever label, that didn't change, right? When we reclassify,
Right, it doesn't.
Anything that was labeled, it keeps that label. So even if it changes call type and you marked it as a correct call, that new classification, if it's changed from call type 8 to 18, it will keep that classification. So just
The
keep in
manual
mind
classification.
the what?
The manual.
The manual,
classification.
it will be now it's an 8 call type 18 and marked as correct, even if you maybe it jumped species. So that's just something to keep in mind. If you've done analysis and you're going to reclassify, you either want to delete the old LFDCS file folder or save it because that's your old analysis, and then make sure you have a new one. We have some ways we went through to fix that. So when we added the humpback call library and reclassified it, some up calls might have changed to humpback or vice versa, and we already had things marked as correct. Before we went through and analyzed for the new species, we looked at previous calls that were classified as correct. So that was that select manual species code where you could do just looking at things that were marked as whatever you want. So correct and unknown maybe, or incorrect, not incorrect, correct and unknown. And then you could change that classification if it switched call types. So yeah, so I looked at, so we had our right whale call library, we had analyzed things, we added humpback call types, reran the data through humpback. Before I went through for humpbacks, I looked at anything that was marked as correct already for humpbacks because they were previously right whale up calls. And I would clear that classification so that now I could mark it for humpbacks and its correct call types, if that makes sense. So just things to think about. I'm happy to talk about it more if you're ever going to do that, but I don't think that's a common issue. So.
Good.
Okay.
Anita, I see your microphone's open. Did you want to say something? Can you move to-
Oh, can you hear me? Can you guys hear me or no?
Yes, you can hear us.
Ooh. Okay. Sorry. I'm just wondering, and if this is outside of the scope of the tutorial, I can follow up with you later, Mark, but I'm just wondering if there's a way at all to, we've got a lot of sound clips that we've pulled out using Raven. And so it seems like to use those to create a new call type, we'd have to like load those in and still go through this process of going through the data and clicking on them to add them in as exemplars. But I'm just wondering if there's any way to do it where you could maybe export or import into LFDCS some sort of like CSV file that has the measurements that you can sometimes get through Raven that might match what you use for your pitch tracks. I don't know if that makes sense.
Don't think that's possible, Anita. And this goes back to how I told you the LFDCS audio is processed. So in order to get, if you have a clip that's like 2 seconds long, it's impossible to get a, it's a challenge to get a background noise to get to your equalized spectrogram to actually produce a pitch track. It's not impossible, but it might take it would take a lot of work. None of the measurements that Raven's doing are useful for creating a pitch track. So that route is not possible either. The system's really designed to pick exemplars out of processed data sets, LFDCS processed data sets, not short sound clips, unfortunately.
But Anita, if you have a bunch of clips and they're in one folder and they're all the same format, you can process that folder and theoretically, if they're pitch tracked correctly, the other thing when you're adding pitch tracks is you want to make sure that call is pitch tracked correctly. Because sometimes pitch tracks, they might find something. So you do want to make sure you're having good pitch track calls in addition to a variety of calls, but the pitch tracks look good. But if that,
You're thinking of her concatenating all the clips together.
yeah,
The challenge with, that's still a challenge because there'll be lots of signal and not much noise because a clip by definition is mostly just the call without a lot to the left or right of it. And so the tonal noise reduction process will take away a lot of the energy that's contained in the calls, and it'll call that background noise. In which
So-
case, the resulting pitch tracks might really stink.
With Raven, you can
so
put a,
it may not
That's
It
work.
might not, it's
But
worth a
it's
try. It
possible.
shouldn't take too long to try that,
Yeah.
but I don't.
I think we did it a little bit. We didn't use exclusively clips from that, but I think we might have tried for some of the Blue Whale, and I think some of it worked. So yeah, it's good. It's worth trying.
If your clips
And-
are, like 2 minutes long, where there's lots of chance to sort of characterize the background noise, that's a different story. That would work fine.
with Raven, you can do a bit of a buffer around your
Mute,
sound
sorry.
clip.
Sorry,
Just a
hold on,
second,
Mia.
Oh, can you hear me? Okay, sorry. I was just gonna say with Raven, you can do a bit of a buffer around you can set a buffer around your sound clips when you're exporting them out from Raven. So there is the potential to get some of the noise around the sounds that you wanna then, as Jen suggested, run kind of process through LFDCS altogether. But I guess I'm just wondering, like, what is a sort of minimum noise buffer you would need for the LFDCS to work well? You mentioned like a 2-minute file, but could you get away with like a smaller bit of a noise buffer around each of your sound clips?
Sorry. You can, and you have control over that. One of the parameters in the parameter file is how long, there's a time constant for the exponentially weighted mean, which means that time constant kind of decides how far back in time to look to create that mean spectrum. So you could set that to something really short. It's just whether that's going to be, it boils down to whether you're going to be able to create decent pitch tracks. The longer the time constant, the better the tonal noise removal. Well, that's not quite true. Anyway, I guess I would say if you have a bunch of clips that you're trying to make into exemplars, you can play games and give it a try. But going forward, if you're trying to make an LFDCS library, I wouldn't pull clips out of Raven and then try to get them back into LFDCS, to get them back into some sort of shape for the LFDCS so that you can run the LFDCS, build the LFDCS call library and use the LFDCS detector. Just process your data and pull the exemplars out all in LFDCS.